Region B. Based on the voltage transfer characteristic curve, the inverter's input voltage is greater than the threshold voltage of the NMOS transistor, but lesser than or equal to VIL. Therefore, the region in green indicates the NMOS gate source voltage. Based on the KVL analysis at the inverter's input, we know that the gate source voltage of the NMOS plus the gate source voltage of the PMOS will be equal to VDD. Since we know that the gate source voltage of the NMOS is the region highlighted in green, the gate source voltage of the PMOS will be the region highlighted in orange. As we know that the threshold voltage of the PMOS transistor is defined as VDD plus VT not P. Therefore, the threshold voltage of the PMOS transistor will be the region highlighted in brown. By visual inspection, we can see that both the NMOS gate source voltage and the PMOS gate source voltage are greater than their threshold voltage. Therefore, we can see that both the NMOS transistor and the PMOS transistor are both turn on. Up till now, we only know that both the NMOS transistor and the PMOS transistor are both turn on. To complete the analysis of both the NMOS and the PMOS transistor, we need to determine, are they operating in the linear or in the saturation region? To determine this, we need to know 1. NMOS drain source voltage. 2. PMOS drain source voltage. According to the IV characteristic, the drain source resistance is inversely proportional to gate source voltage. By visual inspection, we can see that the PMOS gate source voltage is greater than the NMOS gate source voltage. Therefore, we can say that the NMOS drain source resistance will be greater than PMOS drain source resistance. With this information, we can conclude that the inverter's output voltage will be approximately equal to VDD. If the inverter's output voltage is approximately equal to VDD, the drain source voltage of the NMOS transistor will be approximately equal to VDD as well. Based on the KVL analysis at the inverter's output, we know that the drain source voltage of the NMOS plus the drain source voltage of the PMOS will be equal to VDD. Since we know that the drain source voltage of the NMOS is approximately equal to VDD, the drain source voltage of the PMOS will be equal to 0. Therefore, by visual inspection, we can conclude that 1. NMOS is operating in the saturation region. 2. PMOS is operating in the linear region. In region B of the CMOS inverter, the NMOS transistor is in the saturation region. The PMOS transistor is in the linear region.